Welcome to Revit 2019 Demo 34. For Demo 34, we're going to be exploring creating a smart furniture family. Families can be created or found that work in one instance but sometimes need to be modified. What if we only had one size of a window and had to create a new window each time we wanted a different size? We would be AutoCAD. Revit allows you to create modifiable families, so you have the ability to change certain selected properties like width, length, thickness, radius, etc. to meet your needs. We will create a simple table, and from here we will be able to adjust its length, width, height, top thickness, and base thickness. The strategy of family creation will be emphasized. So what we're going to do to start, prior than normal to enter Revit 2019 Demo 34, what we're going to do is create a new family. So on my dialog, because I'm in Revit 2019.2, I'm coming down here to create new Revit family. And then I'm going to look for a furniture.rft. That's a Revit family template. And I'm going to create one from there. So what I'm going to do is it's going to show the center lines and then all of the reference planes that are associated to this furniture family. Now what we want to do is go to the floor reference level, which is where we're at, and we want to make 4 reference planes parallel to the axis. So what we're going to do is we're going to go RP, which is reference plane, and we're going to create one here. And what we can do is we can actually make sure that they're adjusted so that they snap in the correct locations. So we're going from here to here, and then we're going from here to here. And we want to just make sure that these align correctly. I'm not so worried about this distance here, but if I wanted to, I can make sure that they're the same. So we'll just set each one to 4 feet. So I'm just adjusting everything to be at a 4-foot value. RP, same thing. Here to here, set this value, the temporary dimension, to 4 feet. And then from there, what we'll do is we'll dimension to get equal lines. So what we're going to do is DI from here to here, from here to here to here, and then the overall. And then you also want to do the same thing from here to here to here, and then the overall. So you'll notice that. Now, once those are established, you can set these to be equal, which they already are, so nothing should adjust. And then the overall will be set to whatever you have them at. We have not created any geometry yet. So from the front view, what we want to do is we want to go to the front view, and you can see the reference planes that we've created. So we're going to create a top reference plane, and we're actually going to name this one top. So we're going to come up here, and we're going to draw from here to about here, and we're going to call this one top. So that one's established, it's in place, and we're going to create a bottom of the top reference plane a little below the top. So we're going to name that BOT and create a horizontal reference plane between BOT and reference level and name it top of base. So what's going to happen is we're going to hit RP, we're going to go from the same edge here, and we're going to name this one BOT, bottom of table, and then we're going to do RP, and we're going to do one in here that's called top of base. Now, note, we still have not created any geometry, so all we're doing is kind of laying out an idea at this point. So we're going to dimension from the top to the reference plane. So we're going to hit DI, and we're going to dimension from top to the reference plane. And then we're going to dimension from the reference plane top of base, which is this one, to the reference plane. And then we want to go top to bottom, so it'll be this one to this one. So we've got basically a ballpark of dimensions kind of established at this point in time. And what's going to happen is we'll adjust those values as needed. Now we can move the reference planes around, and we'll notice that the dimensions will change. So because the dimensions are locked in, we're in good shape. It's just going to update what those values are. That's kind of how these families are going to start to parametrically allocate themselves. So the concept is we will be moving the reference planes when we adjust the sizes of our table. The table being the parameters that are associated from our identity data, or the values that are adjusting what these values are. and we'll get to that shortly. The geometry of the table will be locked to the reference planes. So notice there are no dimensions here yet. So we're going to hit cancel. Actually, before we hit cancel, I want to show you that there's nothing associated to these values yet. So we'll hit cancel. Now, what we want to do is we want to go to floor plan reference level, which is here, and we want to select the overall length dimension, which is this guy here. And what you'll notice is up here there's a label. Now that label is the ability to add a parameter. So if we create a parameter by selecting this, and we call it length with all caps, this is associated to a family parameter. It's not a shared parameter. We've explained shared parameters in class, and these are incredibly powerful, but for right now, we're just going to create them as a family parameter. And the group is going to be under dimensions, which is automatic, and we're going to hit OK. And what that's going to do is it's going to create the overall length is equal to 8 feet for that particular dimension. So currently we can see that value is length, and we want this value to be depth. So we're going to call this one depth, and we're going to notice that this is associated to dimensions. It's a type-based parameter, meaning as we drop the drop-down based on the type that's selected, it's going to update that value as opposed to instance. We'll get a little bit more into type and instance-based values shortly, but for right now, length and depth are primary and very important. So we're going to change the length to 6 feet. So we'll come up here, and we'll change length to 6 feet. Sorry, that's depth. We'll associate depth to 4 feet at this point, and we'll set length to 6 feet at this point. And you'll notice when I apply that, it updates the values, and it keeps everything kind of constrained within those contexts. Now what I could do is I could create two different types. So the types, because they're type-based, could flex and update, and that drives where this reference plane location is, which drives the value based on what I've modeled. So that's the power of a family. So this is called flexing. As I modify things, it's going to flex the variables based on what the types are in the parameters. So from here, if I change the depth to say 6 and the length to 5, it's going to flex, and you can see it kind of modify in the background to the correct values. So that's incredible value to what we're doing. So we're going to cancel out of that. We're going to go to a front view. So we're going to snap to this front view. And in the front view, we want to select the height dimension. Now the height dimension, we want to add a parameter called height. So we're going to just call this height. Make sure it's in caps. We'll call it height. And it's still type-based, and it's still a dimension value under groups. And we'll hit OK. And it's still a family parameter. Now, from here, we want to select the top thickness dimension, which is this one. And we want to name it THK, thickness, THK. It's a type-based parameter that's associated to dimensions. And then the one below that, we want to associate that to be a base height. So we're going to set this one to base height. And base height is going to also be associated to dimensions as a type-based parameter. Now in here, we're okay. And if I come up here and go to family types, I can highlight. It says allows you to enter parameter values for existing family types, add parameters to the family, or create new types within the family. In one family, you can create multiple family types where each type represents a different size or variation within the family. Use the family types tool to specify the parameters that define the differences between the family types. So in here, if I hit this, I can actually set the base height to 1 foot, hit apply. It's going to update. And then I can adjust the height to 4 foot, which is here, 4 foot, hit apply. And you can see it's flexing. Like as I adjust these values, it's updating that value. So then the thickness is set to 1 foot. We'll hit apply. It's updated. And the reference planes move. We still have not created any geometry yet. But what's important about this is we've created the flexibility of the family within these parameters based on the dimensions and the reference planes that we've drawn. So what we want to do is we want to save this as a table reference layout. And we're just going to save this kind of roughly as a ballpark family for now. So we'll hit apply, hit OK. We'll do a file save as. We'll make sure that we save this family into our families folder that we've created, whether that's on a flash drive or wherever it's being saved and stored. And we're going to call this currently table ref layout. Table ref layout. Now the table ref layout will be the overall family that we're creating. But now let's create some geometry, because that's the most important part, right? Because then we're able to actually see what we're modeling. So we're going to go to floor reference level, and then from there we want to create and set where we're at. So we're going to go create, and we're going to set the reference plane, because you have to do this first. And we want to set this to bottom, which is BOT. And we're going to say OK. Now we're going to go to forms, which is right here, and we're going to create an extrusion. And we want to make a rectangle inside the reference planes. So inside of the reference planes, we're going to create a ballpark rectangle that exists. And the dimensions at this point don't matter at all, because they're going to be associated. Now, our depth is currently set to 6 feet, and our length is currently set to 5 feet. Once we align these values to the plane of what we're flexing, that'll be the most important part. So we're going to align this. So we're going to hit AL, here to here, lock, here to here, lock, and then we'll hit from here to here, lock, reference plane to line, lock. Everything's locked in place. We're going to hit the green check. We're going to go to the front view, and you're going to notice that there's a depth value contained to that. Now this depth value needs to be associated to the thickness. So what we'll have to do is we'll have to align this value to the bottom of here and lock it, so that when I adjust the value of the thickness to be, say, 2 feet, it should automatically update or pull that value down. So in this particular value, it pulled the value down, but it didn't change the thickness. We'll get into that. So what we want to do is we want to go into types, which is here, and we want to set the depth to 2 feet. So we're going to set the depth to 2 feet, and we're going to set the length to 4 feet, and we're going to set the thickness to 2 inches. I'm going to hit apply, and I'm going to hit OK. And we've seen the change, but what we haven't seen is that the top thickness, this should be 2 inches, not 2 feet, is that the top isn't aligned correctly. So I need to align this to the top and lock it. And now that geometry is locked in at the heights constrained to the values that I'm associating. So if I hit SD, there's the tabletop that we're looking at. So it gets incredibly complex in terms of what we're manipulating and what values that we're changing. But as a whole, we want to go into the front view. And from the front view, we want to drag the top down with the blue arrow and lock the rectangle to the top of the reference plane, which you can do. You can drag this value and lock it, but we've already locked it by hitting the AL and aligning that to the top of the value. So that's another way to lock a value. So that's important. Now what we want to do is we go to family types, which is up here, and we want to associate this value to be a depth of 4 feet, a length of 8 feet. So we're going to go 4 feet, length of 8 feet. I'm just tabbing through. I'm going to hit apply, and that's going to flex the values, and you can see it change. This is called flexing the model. If your model did not change, you need to review the process you used and troubleshoot. So we're going to select the top extrusion. We're going to go to properties. So we're going to select this, which is the top extrusion. And one way to check this is if I'm in a 3D view, I can select previous as I selected it, and that's the value. Now in here, what I want to do is I want to go into the properties and adjust the material. I want to associate this to be glass, and I'm going to hit OK. I'm going to use the rendering appearance, hit apply OK, and now I can see that I've got glass associated. So if I've typed in SD, and I can hit HL, so shaded or hidden line, and depending on what you have specified, it will update as so. Now let's do the trapezoidal base. Trapezoidal base. We're going to go to the floor reference level. So we're going to go floor reference level. From here, we're going to make an interior parallel reference plane about where the base might be. So what we want to do, according to this, is we're going to create a couple different reference planes. We're going to create one that's associated here to here, here to here, and I'm just drawing them arbitrarily in space. I'm just referencing them between these two, the midplane and the endpoint plane. And then from there, I'm going to dimension those. I want to dimension it from here to here to here, and I want to hit equal. Once those are equal, then I know that those are associated to those values. So as it flexes, it's going to update. Now, I don't have a base depth set at this point in time, but I will eventually get that in there. Now, what we want to do is we want to create a dimension the same way we did the top with equals and overall dimensions. So we're going to name the overall dimension as base length versus base depth. So I didn't create the other reference planes, but I really want to create some reference planes from here to here and here to here. And I'm going to do the same thing. I'm going to associate this to that length, hit DI. I'm going to dimension from here to here to here. I'm going to make sure those are equivalent. And then what I'm going to do is I'm going to select these values and associate a overall base length. So DI from here to here, dimension, and I want to set that to be the base length, and this has to be caps. So base length, type base parameter, dimensions, hit OK. DI from top to bottom, associative, and then I want to change that value to be base depth. Could be base width as well. In fact, I'd prefer that it's width, but since the handout says depth, we'll leave it as depth for now. So we'll hit OK. And now everything's structured based on those parameters, which means those parameters show up within the library, which means I can then start to associate types, which will flex this family to function in the base value of how this type functions. So it becomes very, very parametric. So we're going to create and set a reference to level 1. So we're going to create, and then we're going to set level 1, reference level, and hit OK. And then from there, we want to create a blend. So we're going to create a blend and make a rectangle. And what we're going to do is we're going to draw the rectangle within this inner length. And I'm going to lock each one of these values to that internal base. And now I want the depth to be 1 foot. And I want the top offset to be 3 inches, which I don't have at this point. So for now, we have that set correctly, and I want the offset to be 3 inches. So that's editing the top of that. Now, using the existing lines, what we're going to do is create a smaller box. So we're going to create an even smaller box from within those. Now, I haven't adjusted those values because that's going to change, but for right now, what we'll do is I will edit the top. So what I'm doing is from the front view, I can see that I've set the base level to there. Now I want to set the top to be different, and that's ultimately what's going to pull it. And now from there, we have our base height set to 1 foot. Now what I want to do is I want to go back to my reference level of level 1, and I want to create and set my reference plane to the next value. Now in order to do that, I need to make sure that I've edited the base is empty, and so I'm now in the top. Create blend top boundary. So what we want to do is we want to create a smaller rectangle within that value. So we're going to set it basically within the confines of this value. Now we'd adjusted that depth, which parametrically flexed it. That's fine for now. We'll go ahead and just set this in here. And if I view this in 3D, I can see the values being adjusted. So the top value's been flexed, and that's why we're getting some issues. So let's undo back a little bit of a ways. And now we're back into basically the creation of this initial base. And that initial base needs to be set and locked in place. And now from that point, what we need to do is create a smaller box. So that's the base. Now we want to edit the top. But in order to edit the top, we want to set this reference plane to be the top of the base. So now we're drawing on the correct reference plane, which means if I draw the top base reference plane as a smaller box, something like, say, this, then if I view this in 3D, I can see that the associative level is changed. So that value has changed. So going to reference plane 1, I could create a trapezoidal feature. So I could actually, rather than selecting that, select all the lines from below, reference planes in this case, trim them together to create that top. So I'm just trimming. And then once I've trimmed, I can set these to be, say, like, let's say 75 degrees. And this one's a little bit, we could mirror this one if we didn't know the exact degree. We could mirror from here to here. And then from there, I could delete this, tr, trim. And now when I hit finish and view this in 3D, I now have that base. I have that trapezoidal base. And you can see that it's pulling and it's associative, meaning if I change that bottom value, it's going to flex and change. So it's time to flex. So what we're going to do is go to 3D, which we're in. We're going to go in and adjust the type parameter of the base or the top. So we want to adjust that top value. And we want to change that base height to 6 inches. Now the question is, did it flex? Did the value actually change? So if I change this back to 1 foot and hit apply, is it adjusting the height? Yes, it is. It's functioning the way that I want it to function at this point in time. So if I change the base length to 3 feet, and I change the base depth to 2 feet, and I hit apply, then it's flexing. It's flexed. So we're okay, we're good. We've checked ourselves. Now we're going to hit OK. We're going to go into a front view. From the front view, we want to pick the base, which is the trapezoid. And we want to go into the properties and adjust a material. So we're going to type in copper. And we're just going to see if it pulls up. It didn't pull up, so we'll create the material. So from here, what we're going to do is we're going to take the default material, which is here, and we're going to right-click and duplicate it, and we'll call it capitals copper. And then from there, what we can do is we can actually find a metal copper material. So if we scroll down and find copper, which is here, we can apply that value to that and keep both. Or we could just delete the one that we duplicated, rename this one, and keep copper. And now that's applied. So if I apply that and hit OK, it's now associative to that family. Now I haven't set the rendering appearance like I could, but I could manage the materials in here and actually use the rendering appearance, and that'll live update the model. So that's very helpful. So now we have the shading, and we've picked a copper color. We hit OK. We're now in a 3D view, and that's ballpark of our table. Now we want to set a centerpiece of the table. The centerpiece will be a revolution, like a turned spindle. From the front view, we're going to create. So we're going to go to create. We're going to set our work plane. And we're going to set it to the center or front back, which is here. And we're going to hit OK. And from there, we're going to go to forms, which is here. And we're going to create a revolve. From the revolve, we're going to choose an access line, which in this case is going to be the center vertical line from here to here. And we want to create a line. So we're just going to create a line from here to here. And from there, what we can do, we want to make sure that's the axis line, which it is not. That's the profile. So we want to hit axis line, choose from here to here. Now we want to go to the boundary line, and we want to create a 1/2 inch or a half of a profile object between the bottom and top of base planes on the left side of the axis. So from here, what I could do is I could do something a little crazy, and I can go down and adjust different values and then set my splines. And I'm just going to kind of draw this thing arbitrarily to how this thing should look. And from that value, it's going to create a revolve along this axis that I'm looking for. So there's the boundary. Now I want to align and lock the top line of the sketch to the bottom. So I'm going to align this to the bottom of the base. So the bottom of the base to the top of the sketch, lock. And I want to lock the top of the base to the top of the sketch, or bottom of the sketch. So if I hit align from here to here and lock it, remove constraints, it's adjusting the constraints as I change it. So I want to make sure I'm selecting the right value when I adjust that. So we'll make sure that we're doing that. Currently, we have the base height that needs to be adjusted to here. Now, what's not changing, though, is the actual base height of the form that we created. So, yes, it flexed, but it wasn't working correctly. So we're going to check that. Notice it revolves that base point. We want to edit this value so that it's locked to the correct plane, so that when I come in here and adjust the base height from 6 inches to, say, 1 foot, apply, it's going to update the values and modify things accordingly. So that's very important in adjusting these revolutions and in adjusting what's happening. It needs to be parametrically attached to each reference plane. And that becomes very complicated when we're doing these things. But what we're going to do is we're going to undo back to here, which we're at 6 inches for the base height. I'm going to edit that revolve, and I'm going to make sure that this revolve is associative correctly. It needs to be correct. And now that's ballpark where it should be. That's what I was looking for. Now, I'm going to check that. I'm going to associate this value to be a red aluminum. We'll type in red aluminum and see what happens. Aluminum. Oops, red aluminum. Nothing. So we'll go ahead and create it. And what we're going to do is we're going to look for the metal, red aluminum. To me, it looks like that's going to be functional. So it's going to be that aluminum, just quickly kind of scrolling through, it's going to be this aluminum anodized red. So I'm going to load that in. I'm going to use the rendering appearance, apply OK. And that's going to overwrite the value so that when I'm looking at this in 3D, that the copper base is there, the red base is there, and now our shading is set to use that rendering appearance. So now when I hit done and I hit OK, I now have a glass top, a red base, and then a red revolve, aluminum red revolve, and then a base. That's all in copper. And if it all flexes, then we're in good shape. Now from here, what is important is when I highlight these elements, I need to make sure that these elements have visibility settings that are associative to the plans that I want to show them. So you control what objects you see from particular views. Example, we may want to see the revolution from plan view. Too busy, especially at the smaller scales. So if I go to level 1, this is ballpark of what we can see at this point in time. I haven't associated the trapezoidal feature to fit within the confines of what the table should be. And that's just because I haven't set parameters based on those top bases, but I could associate reference planes to that internal side to change it from being trapezoidal. But what I want to do is I want to make sure that we turn the revolution off from plan view. I don't want to see it in plan view. So if I go to visibility settings, I can adjust plan view and hit OK. Now from there, we've picked that, we've associated that, and we've changed those detail levels. Now what I want to do from here, from this view, I'm going to hit ZE just to make sure I'm within the confines of the family. And I'm going to save this as a family. I'm going to file, save as, family, crazy table. Crazy table. Now that table's saved. So you've gotten a rough rundown of kind of how those parameters work. Now, let's associate some types to this because we're not done yet. Let's create 3 types of crazy tables, small, medium, and large. So we're going to go into family types, and under family types, we're going to create a new one. We're going to call it small. And then we're going to create another one, and we're going to call it medium. And we're going to create another one, and we're going to call it large. And what's going to happen is we're going to fill this form out for each one. Small is going to have a base depth of -0.5. Sorry, it's going to be 0.5. Oh, it's actually associative. So it's associative to the family. So we want it to be depth minus depth. So the value is actually a formula. So we'll start at 0. We'll set it to depth minus 0.5, so 6 inches. Notice it associates that formula from the parameter to that value. Now we want to set the base length. So base length is going to be length minus 1. Now that value updates to be 7 feet. And now we want length to be 4 feet. So we're going to associate length to just be 4 feet. It's not a parameter, or it's not a calculated parameter. We want the depth to be 2 foot 9 inches. Now that's that type. Now if we move to medium, it's going to follow those standards. So we want the thickness to be 2 inches. Let's make sure we set the thickness correctly here. 2 inches, good. We're going to go to medium. It's 2 inches. Now we want to set the length to 5 feet. And we want to set the height to 4 feet, which it's set to. And we want the length for the depth to be length divided by 2. And we want the length for the base length to be length minus 1 foot, which we have. And we want the base height to be 1 foot. So we're going to set this to 1 foot. And we want the formula to be base length for base depth. So we're going to say base length minus 1 foot. Hit apply. Now I'm going to go into large. And so I'm just building this catalog of how this thing's supposed to parametrically change. And this is the power of Revit, of what we're able to do. So from here, we're going to set thickness to 2 inches, the length to 7 feet. We're going to set the height to 4 feet. We're going to set the depth to be length divided by 2. And we're going to set the base length of length minus 1 foot. And we're going to set the base height to be 1 foot. And we're going to set the base depth to be base length minus 1 foot. Hit apply, OK. Notice I'm not getting any errors, so we're in good shape. So from there, I have the 3 different types that I want. We can make some height changes and discuss the design and how you could adjust the formulas. But how could you begin to control the sizes, i.e. the revolution stretching? And what you'll notice is if we view this in 3D and we change these values to show different types based on what's selected, i.e. large versus small, we can see what's happening to this family. And how could we begin to adjust these? Well, we have to constrain it. So what we're going to do is we've saved it, but we're going to save it again. And we're going to load this into the project and close. And we don't have an open project, so what we can do is we can go ahead and open up our demo 33. I think it was demo 33. So if we go to up a folder to demos 33, we'll open that. We'll pop back to this 3D view, load into project and close. And then when I go to level 1 to place this piece of furniture, if I hit CM, I have that furniture in there. Notice I'm not seeing the inside value that I told the visibility settings not to show me, but I have a coffee table or some kind of table in here. And within this table, I have a small, medium, or large. And as I adjust these values, it's going to update the base values along with other values. Now, I can view this item in 3D. So I dropped a camera, and we can hit SD, and it's going to show us our crazy piece of work. And from here, we can actually start to modify values. So we can duplicate these and do all sorts of stuff. This is where we can begin to set up even more sizes for the table. Notice you have options to change sizes based on the parameters we set up. When we change the parameters, we are actually moving the reference planes, which move the objects locked to them. So from here, I can actually adjust it and view the different sizes in 3D automatically because I've dropped that camera. So that's the power behind what we're doing. So in this lecture, you have learned to create a furniture family with modifiable parameters and materials. You learned to create extrusions, revolutions, blends, lock geometry to reference planes, and flex the model to check to see if your parameters work. So what we're going to do is we're not going to save this yet. We're going to continue through. We're going to continue on as a material as a parameter within the family. So what we can do is we can select the family that we created, edit the family. We're going to open up Crazy Table and select the tabletop, which is this one. And we want to edit the extrusion. So right here is the Edit the Extrusion button. We want to go into Properties, and we want to look at Material. And we're going to pick the far right box, which is this value here. And what this value is going to do is it's an Associate Family parameter box that comes up. And we're going to add a parameter. So we're going to add a value, new one. It's going to be an instance-based parameter. We're going to select that bullet. We're going to group and parameter it under materials and finishes, and we're going to name it tabletop material. Tabletop material. And in here, you're going to notice that the type of parameter is grayed out. So if we hit OK, actually, no, we're in good shape. Nothing's grayed out yet. We're going to hit OK and hit OK. Now that's an associated value. Now if I load this into the project, so if I finish, load into project and close, yes, I'm going to save it. Yes, I want to replace it. Yes, I want to overwrite the version and the parameter value. Now I'm going to go to view 3D, and I'm going to turn and hide by hitting VH my roof, and I'm going to VH my ceilings, and I'm going to view this table, and I'm going to hit SD, it's there, HL, it's not. And so that allows us to do things. Now, if I select this value, you'll notice that the tabletop material can now be changed. So I can come into it and begin to manipulate what material is associated to it. So if I really wanted it to be, say, carpet, I could update that value to that tabletop material. So now I'm starting to associate values to the top of that material to render correctly. So you can make the top any material you want that is loaded into the project. There's some advantages of having material as a parameter when multiple materials are in a family, or the material will be changed in the project often. So one other thing we could do looking at this is we could actually associate and create similar and modify to create a medium value and modify to create a small value of this family. And now we have 3 different values to that table. Now, families and steps to creating families. The important parts are located on 287 inside of the Gallatin College Revit book, and that may change. But currently it's to sketch it, do the math, make the associations through formulas, create the parameters, instance or type-based parameters, adding the formulas to add in what formulas exist, draw the reference material like we did, dimension the reference geometry, turn the dimensions into labels, which we did, and begin to flex that family. And then as we draw it, do the masses and line work associate. And then you'll align and lock the line work to the reference planes and reference lines and flex it. And that'll allow you to kind of ensure that the families that you're creating function in a productive way. That is the extent for this class of how families are going to function and what we're going to use them for, but begin to think about other values and other ways to associate these. If we look at these VW bugs, these are RPC beetles. They are families loaded in as entourage. Now, that's something that you could associate to be 3 different sizes of a vehicle per se, or 3 different sizes of a sofa. Families can become very complicated, but for the course and extent of this class for Revit 1, this will be the extent of those type-based parameters. If you have any questions, please email me or call me, and we can adjust what these or discuss what variables need to be changed to associate to these furniture families. So for now, what we're going to do is we're going to go ahead and hit VV, and we're going to turn back on our ceilings and turn back on our roofs. And we'll go ahead and turn back on our floors because those are off. We'll hit apply OK, and we'll come into a front view here, and we'll just hit File, Save As, Project, and we're going to save this as Demo 34. And I will see you in the next lecture.